I'd like to welcome you to this video, which is the second in the series for Pandas library. And today I am going to talk about the use of some methods for joining and combining data frames. Now, from the previous video, we saw how to create a data frame, and I will start by doing exactly the same. I will show you again how to create a data frame using lists with keys. So to start with, I will run import pandas as PD as per usual, and then I will create the data frames. And in this example, I'm creating three data frames: data frame 1, data frame 2, and data frame 3. And what I am going to do, I am going to print these data frames to show you how they originally look like. Then later on, I will use the function concat for concatenation, and I will pass to it three parameters, which are the three data frames, and I will tell it to actually do it on axis. This concatenation, it has to be on axis equals 0, and this axis can be either axis equals 0, or you can give it an axis like 1, and it will be showing the result in a different way. It will do exactly the same, but it will show you the final data frame where you assign the concatenated data frames in a different way, either vertical or horizontal, and I will explain the difference between the vertical and horizontal as we go through the example. So the first one is actually going to do a concatenation along axis 0, and it's going to concatenate the three data frames, and in this case it will concatenate them vertically on top of each other with index from 0 to the last index of the last component of the third data frame. So let me execute this and see the final result, then we can make comments on the result. Okay. Now, can you see the first data frame? I have the keys, which are A, B, C, D, which are showed here, supplied as keys, and then I have the lists, which are containing A0, A1, A2, and A3, B0, B1, B2, and B3, and so on. And it's actually, the data frame is printed column wise, and then automatically assign the index for the components within that list, which now looks like a data frame. Okay. And the second data frame is exactly the same, but notice that the index continued from the previous data frame to the second data frame, so from the first to the second, and again from the second to the third until the last component in the third data frame. Now, this is for presenting the data frame after creating them. Now let's look at the concatenation, and I said axis equals 0, which means that we are actually going to stack them vertically on top of each other, and that's what happened. We have in A, we have in DF1 we have 4 components which are there. Then they are followed by the components for the second data frame, and then followed by the component of the third data frame. So this is a nice way of actually, if you have scattered data in different locations, you can allocate these data to data frames, and then you can concatenate this data frame to make the final data that you are going to use with your model for either training or testing. It doesn't really which way you're actually going to apply it. Then the second example, it's exactly the same 3 data frames, but what I have done, I actually went and said I wanted to actually concatenate along axis equal 1. And in this case, it will concatenate them. Again, instead of vertical, it's going to concatenate them horizontally, i.e. it will actually put them next to each other. It will stack them, and then it will actually shift data frame 2 to the right, and then data frame 3 to the right of data frame 1. And for the axis that a data frame doesn't have data, it will fill with not a number, which is a nan. So let's see how that happens. In the first one, we created the data frame. These are the keys and these are the axes. These are the keys and these are the axes, and so on. And then I said result, and I called concatenate, and passed to it a list of the 3 data frames, and then again a long axis equal 1, which means they are actually going to be concatenated on top of each other, but they are going to be shifted horizontally. So let's see that is, let me run it, because this is from a previous run. Okay, can you see now I have the data frame 1, and there is no information along these columns for data frame 2 or data frame 3. Therefore, what happens? This along axis actually goes and fill this by nan for these 2 data frames. Then we shift to the right, and then we stack data frame 2, and can you see only data is filled for data frame 2, and because there is no data along these axes for data frame 1 and data frame 2, so what it does, it actually fills all this area by nan, and then it gets data frame 3, which are stacked again below that. It goes all this area here by nan because neither data frame 1 or data frame 2 have any data. Therefore, you can see you have 2 of these concatenation method that you can apply to try and create a new data frame. So it depends on what you are doing for yourself. If you want to go and replace this data with something else to create a bigger data frame which you want to use for your machine learning, or you can bring some data from another location and you can map it into these not a number or nan, which is no data values available in here. So it's up to you what you do depending on the logic that you are trying to execute in your machine learning. So next we can actually talk about how this is done. So a simple explanation: the concatenation function concatenate the data frames horizontally based on their column label. Okay, if the column have the same name in different data frames, the result data frame will have the column with those names, and corresponding value will be filled accordingly. If the data frame doesn't have column present in either data frame, it's replaced with missing values. So let's actually see. We have created 2 data frames. One call is left, the other is called is right, and I passed it the key list, which are key 0, key 1, key 2, and key 3, and then there is a label for the column, which is A and B, and then the column content for A is given as A0 to A3 and B0 to B3. And in data frame 2 we have the same keys also, but we have different label for the data frames. And now what I can do, I can perform a join, and in this case the join will merge these different data frames together based on their keys. So it will take key 0, and then in both because we are using the same key value, it will take key 0 and key 0 from both data frames, and then it actually merge the components in A and the component in C and D and so on. So can you see the result will show A, B and C, and then it will take it for key 0, key 1, key 2 and key 3, as you can see there. And this is key 0, key 1, key 2 and key 3 as they are shown here. And from 0 you can see it has A0, B0, C0 and D0, and that's what we have for key 1 and so on. So what it done, it actually took all the components and it actually merged them together to create a merged data frame containing both of that, and they are passed as left data frame, right data frame, and based on inner, and it says on key. So the keys is important, so we are actually using the key as the point in which we select, okay? And inner means that whatever is actually present in both we will take. If it's not present, we will exclude, okay? So let's look at this when we have non-matching, because this is matching keys in both data frames. But sometimes you will have data which is not matching, and if it's not matching, then the non-matched keys will be dropped. So let's look at an example when we have data which is non-matched. Look at this. It's left data frame we created with K0, K1, K2 and K3. These are the keys. And we created right data frame with key 0, key 1, key 2, and then I have a different key which is key 99, which is only available in data frame 2, and it doesn't also contain data key 3 from data frame 1. So if I try to apply the same logic as I did in the first creation of this result, which is the merged data frame, we should actually have K3 and K99 dropped because they are not matched, because we are asking it to actually on key. If it's on key, then they have to actually match, and because it's inner, anything that's common between the two will be shown. If it's not shown, we are actually dropping it, and we're basing this on the key value. So let's see. I have in data frame 1, I have key 0, key 1 and key 2, and in data frame 2 or right, I have key 0, key 1 and key 2. Key 3 is not available in data frame 2, and key 99 is not available in data frame left. Therefore, when I merge these two, the values for K3, which are A3, B3, and the values for K99, which are C3 and D3, will be dropped from the final result. So if I run this, you should see that actually I only have key 0, key 1 and key 2 available, and the other keys, which are key 3 and key 99, have been dropped, which is a nice way of actually selecting common keys, data related to common keys in your created data frame, because sometimes you want to compare results, or you want to do some calculation based on different months, different years, different companies' name, and so on. So this will be something useful for you to actually find commonality between data frames and just combine these data frames based on what's coming between them. So let's look at the next example. Again, what we are doing, we are actually going to use merge, again on key, and I wanted on inner. So what happens, I am actually having two data frames, left and right, and I have keys, which is key 0, key 1, key 1, and key 2, and the values are A0, A1, B1, B2, and I want to combine them, merge them based on keys, and it has to be the common keys between them. And what's common between these two keys? I have key 0 in the first in the left. I don't have key 0 on the right, therefore I know it's going to be dropped. I have K1 in the left and I have K1 in the right, so these are actually going to be included. I have key 2 in the right, I don't have it on the left, therefore I have K0 and K1, they are not available, therefore I cannot merge, or the result of this merging will not include anything related to key 0 or key 1. Therefore, if I execute this, it should only give me the result related to K1, and as you can see, K1 actually contains, for value X, it contains A1, and for value Y, it contains B1. So that's all we have here in this case. So it's actually this value A1 and this value, which is B1. That's all is common between the two because they are based on the key. Okay, let's see. If I want to merge again and use the keys again, can you see it's the same? So sorry, it's exactly the same as before, and the result is actually shown as exactly the same. Therefore, let me cut this. I've repeated it twice for you. Okay, now let's see another example. The data frame on the left and the right, if I want to merge them based on multiple keys. Okay, so I'm actually going to pass multiple keys. I have key 1 and key 2, key 1 and key 2. In the previous examples, I have just one key for each of the data frames. Now I have data frames with 2 keys. I have key 1 and key 2 for data frame left, and I have key 1 and key 2 for data frame 2, and then I have a list of keys which are actually there for both key 1 and key 2, and as you can see, I have key 0, key 0, key 0, key 1, key 1, key 0, key 2, key 1, and for the second one I have key 0, key 0, key 1, key 0, key 1, key 0, key 2, key 0, and I have underneath the data values assigned to these keys. So now I want to actually merge these on inner, so they have to be what's common between them, and based on 2 keys, key 1 and key 2 for each of the data frames. So if I execute this and then look at the result, you see in key 1 the matching key 0, key 0, I have key 0, key 0, and I have there A0, B0. I have key 0, key 0, and I have there C0 and D0. Therefore, the first one matching is this, which is related to the first column. Okay, then I have K1 and K0. So let's look at K1 and K0. It's this one, K1 and K0, and this one is K and K0. So therefore, let's see. For the first K1 and key 0, I have A2, B2, and I have C1 and D1. So it's this one and this one, which is index 0 and 1. So index 1 in here and index 1 in here. And then I have K1 and K0, which is K1 and K0, which is index 2, and index 2, which is actually A2, B2, C2, and D2. However, I don't have key 2, key 1, because key 2 have key 0 here and key 2 have key 1 here, and I only specified key 1 and key 2 here, but I don't have key 2, which is common between them. So what happens? It actually goes and it drops anything that is not available between the two. I have key 2 here and I have K1, I have key 2 here and I have K0, therefore they are not matching. Okay, so we drop anything not matching and we combine when I say it's inner. Okay, now if I repeat that and see it's the merge, I just want to execute that by itself, I can run it and it actually gives me the same exact same result. It's just because it's in a print format there, it actually gives me a different format where it actually put a line there to separate the keys and the labels from the content of the data frame. Now if I want to use outer rather than inner, it will actually execute in a different way, where it, based on these keys, it will select all the data and it will actually the non-matching data, it will fill it with not a number, nan, which is not available. There is nothing available here, there is nothing available there, there is nothing available there. So if I run this and let's look, now it's different. It's not inner, it's outer, which means that in this case we will still have the result, but it will include all the keys. What do we have? For key 1, I have key 0, K0, I have key 0, key 1, I have key 1, key 0, and I have key 2, key 1. Okay, now for the next one, for B, for the right data frame, I have key 0, key 0, key 1, key 0, key 1, key 0, key 2, key 0. But what happens in some cases, because we don't have anything that common between the two, so what do? We fill it with nan. If it's not matching, then we fill it with nan, and that's what happens. So in the outer join, it includes all rows from both data frames, filling in missing values with nan where there is no match for the specified key column in this example. So that's what it's done. And you can see that key 0 and key 1 from both left and right data frame and the missing values for them. So that's what we have done. For key 1 and key 2, I passed them key 1 and key 2 because we are using multi-keys. And the result where they are not matching, it actually includes all the both data frames. And when data is not matching, we go and enter nan in that area. And look at 1, which is key 0, key 1. I have A1, B1, but I don't have C1 and D. So let's see. For K0 and K0, I have K0, K0. I have A1, A0, B0. I have C0, D0. Therefore, they are all available. For key 0, key 1, I have key 0. I cannot see key 0, key 1 in here. I have key 1, key 0, but it's different from key 0, key 1. Therefore, for data frame right, I will not have any values. And as you can see, we filled it with excuse me, with nan. Let's look at the next key. The next key is K1, K0. I have K1, K0. Therefore, I can go and see what I do. K1, K0 is there, the first one. I have A2, B2. So I have A2, B2. And I have K1, C1, D1. So I have C1, D1. But I have also K1, K0, another one, where I have from from left hand side, I have K1, K0. So I have A2, B2, and the second one I have C2, D2. Okay, because I have two similar keys. The first one I have C1, D1, which is this one. And in the second one, I have the second component, which is C2 D2, because there is a repetition here twice for the same key. Key 2 key 1, I have also key 2 key 1, which is here, and I have key 2 key 0 here. So I will take the components for data frame left, which are A3 B4, sorry, B3, A3 B3, and I don't have anything in the right data frame. And for the second component, which is K2 K0, there is no key in matching key in data frame left. Therefore, I will only include the data related to data frame right, which is C3 D3, and I will put none for data frame left for that component. So this is how we can actually use the outer base of this merging. Okay, so the code PD merge, which is how we need to do right, we can actually do it right or left depending on us. I am actually selecting based on the data frame right. That's what I'm selecting on. Okay, and on keys, therefore I'm looking on these keys, perform a right join between the two data frame based on the specified column, which are key 1 and key 2. Now in this data frame, we take the rows from data frame left if they are matching. Okay, if they are not matching, we do not include them. So I will, because I'm basing my merge on data frame right. So I have selected the priority data frame, which is priority data frame, in this case right, and it will go and give me the results for data frame right. And if there is any matching results in data frame left, which are based on the keys, matching keys, then I include them. If there isn't any matching keys, I will not include them. So let's look at this example using this where I am actually using a priority data frame as a key in this case. So I have two data frames with multiple keys, K0, 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 K1, K1, K0, K2, K1, and I have the second data frame with K0, K0, so they are similar, K1, K0, I have K1, K0, I have K1, K0 again, and I have K2, K1, K2, K0, so they are not available in both of these. K1, K0 is only in one, but it's not in the second, and we know that the priority is right. Therefore, I will include everything related to the keys K1 and K2 in the right, and then if there is a match on the left, I will add them, and I will fill the missing with none. So let's run and see the result now. When you can see from the result that I have K0, K0 is there, both cases. K0, K1, I have it, K0, K1, and I have K1, K0 twice, because I have it once here and I have it twice here. Therefore, I have it twice, and because that's the priority. I include all the keys, K0, K0, K1, K0, K1, K0, K2, K0, and then I look at the data here. Wherever there is a match, I will include the data from here. If it's not, I will put none. So the data for K0, K0 is present in both, therefore I have all the data. K1, K0, I have it available here twice, therefore it included twice. However, is it available in the left? Yes, it's available. K1, K0 is there. Therefore, in both cases, I will take A2, B2. And you can see I took in both cases A2, B2 and A2, B2 in both cases. Okay, what about K2, K0? K2, K0 is only available in the right, it's not available in the left. Therefore, I include the data from the right, and I will put none for the data on the left. So this is also a nice way where I can say the priority of my data. I have data which I want to work on, but priority is the data which is in one data frame. Now there might be data related to the same variables in other data frames. So I want to bring this data from these other data frames into this merged data frame based on similarity. I don't want any differences, I want the similarities. And if there is missing data from this other data frame, then I will put it as none for keys which are not available in these other data frames. So this is how this one works. Let's see when I change this to the left. Look at the data here. It's all related mainly to the keys which are available in right. So my result now on this new cell, when I run it, is going to be related to the keys which are on the left rather than the right. So if I run this, can you see it actually now looking at these keys and including these keys? I have key 0, it's there. Key 0, key 1, it's there. I have key 1, key 0, it's there. I have key 2, key 1, it's there. Okay. Now, in the second data frame, I have key 1, key 0 twice, and it's common with key 1, key 0 in the left frame, which is I'm making priority. Therefore, I will include both of these columns which are in under key 1 and key 0, which are repeated twice in the right frame. And that's the result. And now the result which are not matching, it's actually filled with none. So again, you can see you can either select priority this data frame or data frame, so it doesn't matter. You can change the data frame name which you are trying to prioritize over. Okay, so that's very important. The joining functionality in Pandas, and in here the joining method will take columns of different indexes and it will actually create a data frame from them. So what we are doing, we are taking the method join from Pandas, and we are applying this on different data frames. So in this example, I created left and right data frames where I have keys index, which are key 0 and key 1, and I have the column label A and B for both data frames, and I have C and D for the second data frame. I created the data frame and then applied join on them, and I want to apply join, and I pass to it right data frame. So when I pass right data frame, it will join them for me. As you can see, under column A, it only joined, what do we have? We have K0 and K1. And is there anything for in both? Yes, there is. There is A0, E1, B0, and B1. So it will go and join. Since I am joining on right, that means I look at the right. What do I have for K0 and K1? I have C0 and C1. So for key 2, I have C1 and D1. Where is it? C1 and D1 is there. And for key 1, for key 0, I am actually looking at C0 and D0. And what is related from the same key from the other data frame? I have A0 and B0, and I have A1 and B1, which are from the second data frame. So if I run this result, it should actually join them together for me based on the keys for the data frame, which is right data frame. So these are the keys which we are going to join, and because they are similar keys in both of them, it actually joined all the data for us or based on these keys. So it's just K0 and K0 and K1. So that's it's actually how it's selected. Now let's see if I pass different keys, because I have different keys in these different frames. I have K0, K1, and I have K0 and K2. I have K0, which is similar between the two of them. K1 and K2 are only in individual data frames. So if I say I want to actually use the right data frame, and what do I have in the right data frame? I have K0 available, K1 is not available. So what happens if I run, let me run this to actually see, it's actually K0 and K1, and I applied that. I'm trying to combine, join to the right data frame, left data frame, because I'm passing this here to join. So it will take the index values, and based on these index values, it will actually go and join. So what do I have? K0 and K0, I have both of them there. K1, I have only for the left hand side, but I don't have for the right hand side. Okay, so what happens here? You can see that D0 and D1 are actually dropped. They are not there. Okay, because I am actually trying to combine base. I'm joining right data frame with left data frame. Therefore, you can see, what do I have here? Key0 and Key1. These are the keys. Do I have Key0 in the right hand side? Yes. Therefore, I will include the left followed by the right. I will go to Key1. Key1, do I have it in the data frame, second data frame, which is the right data frame? No, I don't have it, but I have it on the left. Therefore, I include the left and I drop the right, and I will say this is the replaced by nan. So I fill it with nan rather than leave it with nothing. Okay. So again, if I want to combine results, this is we've done this before. In this example, missing values are none. Okay, so nothing here. Outer is actually the outer data frames. Operations. Okay. Now, you can go and reference the documentation for Pandas, where Panda will actually have a lot of examples, and these examples which I am using, I am taking them out of the documentation, most of them, and I actually customize for the sake of this exercise whenever I have to. Now, what do I want to do? I want to select columns from data frames by passing the column names. So what I did, I created a data dictionary here, and I assigned it to this variable data, and then I created a data frame from this dictionary. Then I wanted to select from this data frame the values which are related to A and C. I am not going to pick B, I'm just going to collect A and C. And then I can actually go and collect it the first time by passing these information, or I can actually use location. Okay, there is a method called location. I can actually use that to select the data in the given location. So I can give it either in the form of a list of the two columns that I want to do, or I can say the location, and I can say all the information within these locations. And if I run this, you can see it actually give it to me in two ways. First of all, I am actually printing selected columns, and then I use the method location, and it actually provides me with the same result. So this way or this way, you can actually access your intended result, the result that you intend to see or to use in your code. So you can actually select this result, assign it to a variable, use this variable in some functionality that you are trying to execute on this data. Okay, can you see this command here, data frame head? And this data frame head, what it will do, it will actually go and print the first few lines of a data frame. If you have a data frame and you don't know what the actual data look like, then you can just use this function head by just calling the data frame and then calling the function head and executing that. It should actually give you the content of the first maybe 4 or 5 rows in your data frame. It will include all the columns, and you will see when you have a lot of data in your data frame, it's confusing for you to actually see and to understand the different types. Therefore, this is a nice way, quick way for you to access the data and just to view what's available there. Okay, we can also use print to show the same thing rather than just using the data frame call. And in there, all I have to do is just to call this function within the print, and it should actually give me, can you see, it actually gave me the same information which are there or there. It's exactly the same. It actually formatted it nicely for me. Now, I can also, on data frame, I can filter data based on some logic, okay? And in this case, I am actually filtering data which are in key, under key 1, but I want all the data that's greater than 1. And what happens here, I'm actually passing A. Therefore, I'm selecting the data here, and then I select the data which are related, which means at the same index in the other data frame will be showed for me. So I have greater than 1, I have 2 and 3. So what do I have from data frame, in the data frame under the key A, I have, I have on the 2, and I have 5, and I have 8 in these 3, under these labels. And then if I say I want 3, because 3 is greater than 1, then I have also 3, I have 6, I have 9, therefore it displays it for us. So if I say greater or equal, also it should give me some other information. In this case, all the data is actually greater or equal to 1, and it goes and showed me all this data. Now I can change this and make it 2, and I make it greater than 2, and then what does it actually give me? Give me the information. It has to actually select them based on whatever is in A, because if I say greater than 3, what happens? I don't have anything greater than 3, therefore it hasn't selected any of the information here. So if I know what I have in my data, then I am able to actually select the information based on this logic. So I can enter the logic here, and based on that, it will actually select the data frame for me. I can change that to actually make it where it actually select based on the modulus, and in this case, if I'm looking for even number, it will give me just for 2. If I'm looking for odd numbers, it will give me for 3. And I would advise you to go and try this for yourself and add some more logic, probably add some more information in the data frame when you create the data frame, or read something from outside, because I will show you how to actually do that in the next video, where you can actually bring data from outside into you and create a data frame with it, and then apply some functionality. So maybe you can do that on let's say an Excel sheet that you have data in it or something, and it will actually give you some more meaning to the logic that you can apply here, because I only used a simple example for the sake of this lecture. Okay, next thing, we are actually going to group by, and in this case I am grouping by company, so I'm actually using the key company, and then I am also passing to that the mean of the sales. So this is the companies. I have A, B companies, and then I have sales for A and B, and then I want the actual mean of the sale. So I am grouping them first, and then passing to this the sales, and I'm actually trying to calculate the mean for it. And if you look at the mean A and A, which is 100 and 200, sorry, 100 and 200, which is 300, and the mean is 150. And for B, I have 150 and 250, therefore the mean will be 200. And that's what it's actually done. So let's run this and see what happens. Now, if we change this to make it 350, and if I run it again, you will see the actual means have changed. And if I make this into 1,000, and if I run this, you can see now the values are actually changed. Therefore, this, when we call this mean method, it actually goes and calculates based on our selection. And what we are grouping by, we are grouping by company. Therefore, I'm looking for A and B, and I have two of these components for A and B, sale components. Therefore, it will look for the mean of 1,000 and 200. It will give me 600, and a mean for 350 and 250, it will be 300, and so on. So you can create a data frame that contains more data, and you can actually apply this, and you can see it's a nice way of calculating the mean if that's what you are interested in. Now, there is a lot of methods that you can apply, and I can only use so many in this video. I cannot show you all of them, but I'm showing you how you can actually utilize it. So I'm grouping by company. That means whatever is there, it's actually going to be grouped by. I have A and I have B. If I had C and D and E, then I will have A, B, C, D, and E. But because I only have two companies, therefore it actually grouped them according to the companies. Then it goes and calculates the mean from the sales entry. So this is how it's done. Then I want to group by A, and what happens? A is actually containing 3, 1, and 2, and B contain 6, 4, and 5. And what I want to do, I want to actually sort them by value, okay? And sort by value will actually start from the minimum value to the maximum value, and I pass A. Therefore, I am sorting A, but at the same time, I will tell you the relevant component that is available in B. So I have 3, opposite that I have 6. I have 1, I have 4, I have 2, I have 6. So when I sort A, it will be 1, 2, 3, which is 1, 2, 3, and then it will take 1, what's available in B is 4. Therefore, it will tell me this is equivalent to 4. 2, it has an equivalent of 5, and 3 have an equivalent of 6. Therefore, it will print them in that manner for me, sorted according to A. If I ask it to sort it according to B, all I have to do is just to change the key here, and the sort will be different. Now I have 4, 5, and 6, and what do I have? I have the relevant, which is 1, 2, and 3 accordingly. So I can sort it any way I want based on these keys, and this is a nice way of actually sorting your data when you have data that's shuffled. Okay, I want to look for unique numbers. Okay, and what am I doing here? I am actually creating a series, and this series is actually, I pass to it a dictionary and create a series, and then I apply the method unique, where it will actually go and look at this series which contain A, B, A, C, and B. So I have A repeated, but I have I have B repeated, but I have C which is single. Therefore, if I'm looking for unique, there isn't going to be any repetition. I will have A, one of A, I have one of B, and I have a C. So let's run this, and as you can see, it has actually sorted it for us. And don't forget, series is actually printed in this manner as a row. When we look at some other results, and I will, even though it was actually data frame which looks at columns, but there is some conversion using stack. We convert it back to a series, do some execution on it, and of unique, let's say, and then present the data. So let's see, what do I have? I have a dictionary with 2 keys, category and value, and the categories, which are the labels, are A, B, C, and B, and the values are 10, 20, 10, 30, and 20. What do? I actually go and create a data frame. So if I go and print this data frame, let's actually put a print data frame. Let's see what happens here. Okay, I have actually printed the data frame that has been created. This is our data frame. Then after that, I am using unique on the column. So I passed the category, which is this one here. So this one is actually passing A, B, A, C, B here, but I applied the method unique on it. Therefore, it will draw. So I end up with A, B, and C. Okay, and then I print that, and I have A. And in the last one, I called the stack on the data frame, and this will convert the data frame to a series. Then I applied this unique again on this series, and what it did, it gave me A, which actually have B, 10, and B that has 20, and C that has 30. So it dropped any repetition. A has 10, so it took the first A, it dropped the second A. Okay, the second A, what does it actually contain? 10 again, but it only took one of them. B, it actually contained 20, and B contained 20, therefore it dropped the repetition and kept me just the unique values here. Okay, now let's see. In this example, what I wanted to do is to count the series. So what I have data frame created using this category, and then I wanted to actually go and count how many times A is repeated, B is repeated, C is repeated. So I passed this category, this dictionary category, to our data frame, and then based on that I went and did a count. So I used the value count method to actually count for us how many times C are actually repeated, and you can see A, I have 2, B, I have 2, C, I have 1, and that's the result. So let's run this. It's correct. So I now want to select by indexing and slicing. You remember we did all this with numpys, and we did it with lists and dictionaries when we were looking at how we create them in series. Therefore, we can do exactly the same here. I have this dictionary, which actually have the keys name, age, and city, and I have a list assigned to each of these keys, a list of text, a list of integers, and a list of more text, which is actually the addresses. I created this data frame from this dictionary. Then I actually went and selected based on the key, which is the name. So I passed it only one key, and it actually goes and give me the key, anything related to the name. So it will give me Alice, Bob, and Charlie, and it will give it in a column format, as you can see. But if I go and ask for related ages, then it goes and give me the related ages. If I go and add address there, then it will go and give me the address, and each time it should actually tell me what it's doing. So let's run this, and as you can see in the first print here, I printed this based on name. I printed the second one based on name and age. Therefore, I can change it as I want. I can also select by rows and by index. So I have now the same data frame, which is actually data dictionary containing the same information as we did in the first part. Then I create a data frame where I pass to it data, and at the same time I pass to it the index I want to use. So I don't want to use the index as the keys. I want to have customized index, and then I go and do the selection based on a location, and in this case from the indexes that I have. I want index 0 or index 1 or index 2 and so on, but my indexes here is A, which are the labels A, B, and C. So I want to select A, and based on that it should give me all the information related to A, which is Bob, and then 30, and the address, which is San Francisco. So this is B. In this case, B is the second index here. So Bob, 30, and San Francisco. If I change this to A, then it will give me Alice, 25, and New York. If I make it into C, then it will give me Charlie, 22, and Los Angeles. So depending on what I select, it will actually give me the results. So since I have formed the indexes, I used the indexes which are given from the dictionary, the keys, and I can select, or I can actually do it from the index itself. So if I change this where I can add another index there, let's say I have B, then if I run this, and what I did here, I actually asked it to print, and I passed it to location as if I am passing a list. And in this case, it's actually confused because I shouldn't be passing commas, which is not the same as here. Okay, look at the error that I obtained here. It says selecting rows by position. B is not actually unknown to it. But if I go and change that and remove it altogether from the command, and run this again, you can see there is no errors. If I go and try the slicing, and run this, it actually goes and give me based on the slicing. So it's actually taken from C to B, and the data frame, what are the index? So it's actually age and city. So it actually gave me the age and city for that location. Therefore, I need to be very careful how I use this. And I advise you to actually play with it to understand how we actually do that. Okay, now I want to select by index location, and here by location A and B. Therefore it didn't work for us when I worked at it last time, but in here I have index location, even though I am using location, and it's actually what I have entered here. Okay, now if I have index location and I pass this to it, let's see what happens. It actually go and give me that. Now if I go and ask it to give me 2, then if I run this, it gives me the information related to 2. If I ask it to give me information related to 0, it will give me the information related to Alice, because Alice is at location 0, this is at location 1, this is at location 3, and so on. Now if we are selecting on the category as we did before, and I pass to it the name and the age, this now it worked, because what I was showing you here when we tried passing the index, I said let's actually print what's for B also as well as C. It actually went and gave us the information, but when I used the indexing there, which is the slicing, it actually went and gave me some information. Now I am actually passing A and B, so it's these two which are actually Alice and Bob, and then I said I wanted just name and age. I don't want address. If I want address, I have to go and actually ask for C as well, but I did it. So I can select based on selected values also. So I asked for A and B, and then I wanted selected values. So when I run this, it should actually give me the selected information. Now we can go and apply some functionality to the data frame. So I have a data which is made out of a dictionary with key A and B, and it has some components which is 1, 2, 3, and 4, 5, and 6. I created a data frame, then I used the lambda function, which we have seen the lambda in previous videos. The lambda will take a value, and then I have to apply some logic within that function lambda, and in this case the function which we have used many times before, which is returning the square of the value we enter, should actually give us an output of the square what we enter. So I have created the data frame using this dictionary. Then I created a function which is a square function using lambda functionality. Then what I did, I wanted to select based on B squared. Okay, I wanted to select based on B. Therefore what I will do, I will take B and then I will apply a square to it, which means I have 4 squared, 5 squared, and 6 squared, but A, I didn't apply any square, so it will actually display it as it is. So if I run this, it actually squared B. Now I can change this where I can say squared A, and I can pass to it A, and if I run this now, it will square the content of A, the column A, and it will leave column B as it is. So can you see I have the 2 columns, one A and B, but I also have the actual square which I applied the function. So I used the method apply to apply this square function. So I call this square function within my method apply. And this is a nice way of applying some function. So I have a function and I want to apply it. I will actually use the method apply, and I will pass that function to there, and it will be applied based on what I have decided to call it on. And in this case, I use it on data frame, and I filtered it based on A. So I'm actually just squaring the column A, and I'm leaving the rest of the columns as they are, because my data frame can have as many columns as needed when you are working with data frames. Okay, I want to actually create a data frame again. It's the same data frame as before, and I want to apply a NumPy function on that. So what did I do? Created the data frame, then I called a squared, and you remember what we did? We actually did a squared here. So, and I will use NumPy to actually do the square of A. So I'm actually now squaring the column A, but I am using the function square from NumPy. So therefore I need to run NumPy for this to work, because if I don't include NumPy, it will not work, because I'm using NumPy. And I call from NumPy this square, and then I pass to it the data frame and the filter that I am actually trying to select for squaring. And if I run this, it should give me exactly the same result as we have here, even though it's a different from apply. In there I use the method apply, and here I'm using square, okay, from NumPy. So if I want to change this where it's actually B, I can change this, and I can change the filter here, and it will be B. And if I run this, it will actually now give me the square of B. Now we can also use apply in this case, and we can map columns, which means I can actually take a sorted function, and then say against 1 there is 4, against 2 there is 5, against 3 there is 6, and I can square these values based on the functionality. Okay, so let's see. I am actually trying to create the data frame here. Then I want to create a square function using Lambda, which we have seen earlier, and then I created a square data frame. What do I have? I have 1, 2, and 3. I have 4, 5, and 6. And when I want to do that, I will apply Lambda on the columns, and then I map to the square function. So, and then I will print this squared function, which is the data frame that's being squared. In this case, as you can see, it took A, column A, and 1 squared is 1, 2 squared is 4, 3 squared is 9, and then 4 squared is 16, 5 squared is 25, and 6 squared is 36. So it's actually a nice way of applying these functionality. Now, I showed you at the beginning of this section, which is applying functionalities, and you can see here I said there is at the beginning that the documentation for data frames is for Pandas is actually there. If you go to that, if you click on that, it should take you to this Panda document. And if you go to getting started, and then it tells you working with Conda, how you work with Conda, what kind of data does Panda handle. It talks about data, how to read and write. It tells you how to read and write. How do I select subset of tables? It tells you how to select plots on Panda. It tells you. So there is too many things that I haven't covered, and they are actually there, and it will be very useful for you to actually select and work with. So this is all I want to talk to you about today in this video. I will stop this video here, and I will hope to see you in the next video. Our next video is going to be very short, because I will show you how to read data into your data.